Dear student, now I explain the step and time response of second order system. Aim: to simulate a typical second order system and determine the step response and time response of specifications. To evaluate the effect of additional poles and zeros on time response of second order system. Third one, to evaluate the effect of pole location on stability. Fourth one, to evaluate the effect of loop gain of a negative feedback system. Apparatus required: PC loaded with MATLAB. Then, theory of this experiment: the time response of the control system consists of two parts. One is transient response, another one is steady state response. That is C of t equal to, that is C transient of t plus C steady state of t. Every system has a tendency to oppose the accelerated behavior of the system, which is called as damping. The damping is measured by a factor called damping ratio of the system. If the damping ratio is very high, then there will not be any oscillation in the output. So the output is purely exponential. Such system is called the over-damped system. If the damping is less compared to over-damped, then the system is critically damped system. If the damping is very less, then the system is under-damped system. With no damping, the system is undamped. So the damping ratio zeta value 1 less than zeta less than infinitive is nothing but over-damped system. Zeta equal to 1 critically damped system. 0 less than zeta less than 1 under-damped system. Zeta equal to 0 undamped system. Then time domain specifications. Generally, second order system is represented by the transfer function C of s divided by R of s equal to omega n squared divided by s squared plus 2 zeta omega n s plus omega n squared, where zeta is the damping ratio, omega n is undamped natural frequency. Then percentage maximum overshoot, that is percentage MP equal to 100 into e power minus pi zeta divided by e of root e power root 1 minus zeta squared. Peak overshoot time Tp equal to pi divided by omega d equal to pi divided by omega n root of 1 minus zeta squared. Then raise time Tr equal to pi minus theta divided by omega d, where omega d is nothing but the damped natural frequency, which is equal to omega n root of 1 minus zeta squared. Then delay time dt equal to 1 plus 0.7 zeta divided by omega n. Settling time Ts equal to 4 divided by zeta omega n for 2% tolerance. For 5% tolerance, settling time Ts equal to 3 divided by zeta omega n. So these are the time domain specification we are used in the program. Then this is the model graph of the second order system. That is the step response of the second order system. You know, x-axis time, y-axis v of t, and then MP is the maximum overshoot, TD delay time, TR is the raise time, TP is the peak time, TS is the settling time. Then procedure. I consider one transfer function C of s divided by R of s equal to 1000 divided by s squared plus 20s plus 1000. So this is actually standardized transfer function of second order system equal to what? Omega n squared divided by s squared plus 2 zeta omega n s plus omega n squared. Now you can open the MATLAB command window, then click on file and then click new and then click M-file to open your MATLAB editor window. In the MATLAB editor window, you type the program and to obtain the step response, save the file in the work diary, then run the program and enter the respective value of natural frequency, damping ratio, settling time, rise time, peak time, delay time. The graphs displays are according to the above values only. Then select the submenu. The LTA viewer displays the respective marker on the plot. Click the marker and hold the mouse button down to read the values of the plot. If left click anywhere on the particular point to see the response value of that plot at that point only. If right click in the plot region, this opens the following menu list, that is systems, characteristics, grid, normalized, full view, properties. If you can click, that means system means the waveform is in the blue color. If you click characteristics, again submenu is peak response, settling time, rise time, steady state. If you can click, for example, peak response means the particular waveform, the peak point you should know. Then settling time, rise time, steady state. And then you can full view click, you can get the full view. Grid means the line will come. If you can, and that means not click means then line won't come on the plot region. The same, the repeated steps, the 5 and 6, 7 for the different values of zeta. This is the procedure. Then program. Here four part is there. First one is we have to get the second order, that means step response and time response are the specification. So the left hand side the program first clear, then program C of T means I want to get the step response of second order, and then numerator. My equation is 1000 divided by 1, that is the s squared plus 20s plus 1000. So that's why numerator 1000, denominator that means 120,000. G means that is a system. TF means a transfer function. Transfer function means numerator divided by denominator. That is C of S divided by R of S. Then KP, that is the gain, that is the DC gain. That system means G. ESS means that is the steady state. That is response 1 divided by, the formula is 1 divided by 1 plus Kp value. The W means that is the omega n, square root of denominator 3 means that is the 1000. So therefore root of 1000, that value only you have to get the omega n. Zeta is the denominator 2 divided by 2 multiplied by omega n. So denominator 2 means 20. Upper 20 divided by 2, that means multiplied by omega. Then TD already you know 1 plus 0.7 zeta divided by omega n, that formula. TS means settling time 4 divided by zeta into omega n. And then peak time that means pi divided by omega into square root of, that means 1 minus zeta whole squared. Then TR means raise time, that is the pi, that means turn inverse, that formula. Everything the formula only. Then maximum overshoot is the e power, that means minus pi zeta divided by square root of, that means 1 minus zeta squared multiplied by 100. Then step G means that is a system only. We want that is system response. This is the program, that is the logic of a program of first part. Like that you get the output. After simulate the program, you can get like this. The left hand side what? X axis time, Y axis amplitude you can get. I told no, you have to go to, that means left click means we will come what is system G, time point 108 amplitude. This is the left click. If you can right click, right hand side diagram, you can get right click means that is the characteristics. Click means what do we get and all? Peak amplitude, rise time, settling time, and then steady state value only. In this case, without grid only we are getting the waveform. If you can click grid, that the line will come. This is the first part output. That is the step response of the second order. Then second one is the effect of the additional poles and 0. In this case, we can add the poles. For the particular system, the pole is that minus 10 plus 30i and minus 10 minus 30i only, and then zeros also. So now you can write the program. First I am adding the 0 and all. So in this case and all, this is I am considering the system G1 and all. So in this case and all, I have to the numerator on the conversion of the previous numerator of 1 and 1 only. So in this case, I have to find raise time, peak hours, maximum peak overshoot, everything, and then you can pole values and then 0 values. This is adding of a 0 and pole to this. Now you can for that particular program, what is the output you can see. Pole 0 map. 2 poles minus 10 minus 30i minus 10 plus 30i and then 0 for the particular second order system. In the right hand side this waveform you can see time versus, that means amplitude. We can get the rise time, peak hours and then maximum. Like that we have to get the output for running that program. Then next third part is to evaluate the effect of the pole location. We can add only pole on the stability only. In this case, this system I consider G2. That means what? I take the conversion of denominator only. That is denominator 2 only. Okay, denominator 2 only, conversion denominator 1 0 only. Then KP gain, steady state, step. I want the step state and then stability only. Now you have to run this program and all. You can get the waveform like this. You can see steady state. You can kick left kick system G2. Time in second 18.4 amplitude will come. In this pole 0 map and all, you can get the pole. This is the effect of the poles only. So we are getting the poles for the particular second order function only. Then fourth part is, that means to evaluate the effect of loop gain of a negative feedback system on stability. In this case, what we get different values of k. What value I am choosing? K1 is equal to 1, K2 is equal to 2, K3 is equal to 3. In this case, Z clear. Z means that is a 0, then pole, then K1 means that is the loop gain value, different value. So the different system. If K1 equal to 1 means system 1, K2 means system 2, K3 means system. And then again I said the time means the values. What are the K value? From 0 to 1, the steps is 0.001, that is the time. I want the output only. So if you run this program and all, we are getting the output like this. In this line you can see I give the grid command in the program, that's why grid line will come. Okay, so therefore this is the, you see blue color is k is equal to 1, green color k is equal to 2, then red color k is equal to 3, like the for different value of loop gain. This is the effect of the loop gain on the second order system. Other than that, I take one transfer function, I vary the zeta value. For the various value of the zeta value, then what is the second order response? Okay, I choose the transfer function 25 divided by s squared plus 10s plus 25 only. For this system and all, I write the program clear zeta value. I assign 4 condition: underdamped, and then undamped, critical damped, overdamped. 4 condition I choose the value 0.0, 0.6, 1.0, 1.5. Everything I mentioned, I use the leg end. What is the leg end command means? In the waveform and all, the corner and all, right side corner and all, it will come. Before we see k is equal to 1, k is like that will come. That is the command is leg end command only. So I here the time means 0 and then 0.2 colon, that means the 0 to 10, the step is 0, 0.2, 0.4, like that only. Then the numerator, our function is what? 25 divided by, that means s squared plus 10s plus 25 only. That n is, that means 4 conditions, no? Undamped, underdamped, critically damped, overdamped. Then I want output, then n, then plot y. If run this program and all, you can get the waveform. The blue color is nothing but what? Undamped system. The 0.6 value, if the 0.6 value means that is the underdamped custom. And then 1.0 means that is the critical damped custom. Zeta is equal to 1.5 means overdamped. The corner automatically will come, that is the leg end command we give. Now I explain all the theory, procedure, programs, what type of the output we are getting. The same output only we get for That means when we running the program only. This is the video that means a link of a demo of a step response of the second order system. Now I explain the step and time response of second order system. Aim to simulate a typical second order system and determine step response. Second one, to evaluate the effect of additional poles and zeros. Third one, to evaluate the effect of poles location on stability. Fourth one, to evaluate the effect of loop gain of a negative gain feedback. Then fifth one is for the various values of zeta, we have to get the waveform. Apparatus required, PC loaded with MATLAB. First, you can open the editor window, type the program. Before typing the program, you know the formula of time domain specifications, that is transfer function, steady state response, loop gain, zeta value, natural frequency value, delay time, settling time, peak time, rise time, percentage maximum, and all the time domain specification formula you can write and then calculate value theoretically, and then you can type the program in the editor window and then saved as a .m file. Now you go to file, then you can open, your file is open, now open is one, then you can save. After that you go to debug. This part is the first part, the program C of t is the only second order function. This is the program C, Z of t is the, I add the 0 to the given system, that is the effect of 0. This is the adding pole means CP of t means effect of pole. Then this is the effect of loop gain K. So that the 4 part only. So now you go to debug, run the program, got the output on the screen only. You see the first one, this is the first part, this is the program C of t. Okay, second order waveform. What is the second order? 1000 divided, numerator 1000 divided by 1 means s squared, 20 means 20s, 1000 means plus 1000 only. Okay, then next you can in the waveform and all you can left click, you get the system G, that is the what is the time amplitude. Then right click systems, system means blue, our waveform is blue color. Then you can characteristics, click characteristics, peak time. You click peak time will come here. Then click settling time. Then rise time. Then steady state. Now you go to this point. You can left click. You see rise time. What is that time? Here again you go to left click. That is the peak amplitude. That is the peak response. This is, you can left click, settling time will come. Here you can click and left click, you can get the steady state. These all are comes under characteristics. Grid means you can click, grid means the grid line will come. Okay, if you don't want grid means you can remove, means grid won't come under. So this is the zoom. You have to zoom, you have to whether XY plot, XY, you can zoom it. This is the properties under, you can change the properties. Okay, this is the first waveform C of t only. Then second one is this is the effect of pole. For particular transfer function, the first pole is minus 10 plus 30i. The second pole is minus 10 minus 30i. This is the effect of pole. Then again 0 and all, go to second order. Here you can click, this is the raise C, that is the Z of t, that is the pole only. Then again peak value of, then again is the maximum peak overshoot only. This is the third waveform. The fourth one is this is the pole 0 effect. This is the pole, first pole, second pole, this is the 0 for the given second order system. Then again steady state, you have to click left click, wherever you want left click, you can get the time amplitude only. Then next you can here you can click, you can get is the delay. This is the poles, first pole, second pole, another one pole is 0. Then loop gain and all, this is the loop gain waveform. You see, this is the loop gain waveform. You can get k is equal to 1, 2, 3. Red is k3, k is equal to 2 means green, and then blue is the k1. This is the 4 part only. Then now you can vary the for the different values of zeta value. Open the program, you can save it, go to debug and then run the program. You can get the waveform. This is the waveform for different values of zeta for the given, that means second order system. We are getting the waveform zeta over damped, critically damped, under damped, and then system damped. So here and all 5 only. First one is second order, then pole effect, then zero effect, then loop gain, then for different values of that means zeta value. Thank you, students. The next one is the result. You can write the 4 part. First we can get the time and step response of the second order system. Then effect of the poles and zero of the second order system. Effect of poles on the stability, and then effect of loop gain. Then some example of the Viva question for this experiment. What do you understand by MATLAB software? What does MATLAB stands for? And then what is the transfer function? And then what is the peak overshoot and the percentage overshoot? And then what is the peak time? Everything with answer only is there. And then another more question. What is settling time? What is rise time? What is transient response? What is damping ratio? What is steady state systems? Thank you, student, for watching this video.